This is Mario with MI Microflight once again, and in this video I'm going to be talking about the control panel for the electric go-kart that I showed in some other videos. That go-kart was built by using EMT conduit, electrical metal conduit, and maker pipe connectors. Strictly, there is no welding whatsoever in that cart. And this is my power delivery system here. Two Ryobi batteries, 18 volts a piece, 36 volts DC total, feeding two of these speed controllers, which independently control each of the brushless motors that are driving that go-kart. I have this hoverboard here opened up as an example, because it's what I've been using to test it, so that I don't go outside and connect this to my go-kart yet. The weather's a little bit hot, and so I've been using this hoverboard, to test the motor here, to test the speed controls and make all the settings and get familiar with all the controls. In addition to getting familiar with the controls, I did this panel here that you see here. And basically, here's a diagram of that panel. You can probably see it better in the diagram as far as the designations. I have things such as brake, lights, flasher, lights main, left LED, stop LED, right LED, the on and off key, the horn. I have here the cruise control, reverse, 3-speed, and some additional sockets here, the USB socket and another switch here for some other things. And so I basically did this panel on a piece of board. Originally I did just a mock-up just to get a basic shape and fit it into the go-kart. And then I decided to take this on the computer and did this it's a 3D print a piece here. This is a PLA right now, but I can always print this in some other material. I did this rather quickly just to get a second iteration of that design, to make sure that all my holes were at the right size, and to see how this would look as almost as a finished piece. It normally takes me 3 tries or 3 iterations to get to the final product, and so this is my second one, but it came out good, so I will leave it at that. What we have here is this is for a flasher. If I want to turn on flashers on my go-kart, I can do that. If I'm riding at night, or when it's when the daylight starts running out, I can turn on the flashers just for safety. For somebody that might be in back of me when I go to the park or to somewhere. This is not a car that you would ride on the street for safety reasons, and also it's not a car made for racing, for professional racing, because it's just a fun project. Let that be out so that people know the intent of this project. And I did it more to see if I could use EMT tubing with maker pipe connectors in a very creative way to achieve a go-kart. There's another gentleman that did another go-kart prior to me showing my cart, and so credit goes to that gentleman for also making a go-kart with EMT and the maker pipe connectors. But he used a bought axle. He bought a live. He used a different motor than repurposed hoverboard motors, and he also went and bought some parts such as the front axles, for the front wheels, and some other pieces. So it's not totally the way that I did mine. I mean, I got really creative with mine, and I did my own axles, my own C brackets. Everything was done with the EMT tubing and maker pipe connectors. So and I'm repurposing some of these hoverboard motors, so that's a big difference in the go-kart. Otherwise, EMT tubing and maker pipe connectors have been used before by not only by me or the other gentleman, but other people in making all sorts of contraptions and vehicles. So getting back to this panel, we have the starting on and off switch, key switch here, and when this is on, this LED will light up, so that you have a visual indication. I wanted to have visual indication on everything here, and that's the reason why I went with lit up switches. All these switches light up when they're active, and the ones that don't, such as this one, this is a 3-position switch. low, center, and high. Center means regular speed, and this is a 3-speed control to control the speed of the go-kart, because these controllers do have those provisions, to allow the go-kart to engage in a lower or higher speed. And so I decided to use pretty much everything that comes with these controllers. In my first go-kart that I built just out of telescopic tubing, you'll see that I also talk about the controllers a little bit, but I did not use all the switches. All I did was use the motor control, the sensor, for the motor. This is the Hall sensor that comes out of the motor. The three, obviously the 3 connectors that you need for the motor. Basically, here's a motor, and there was this Hall sensor and the 3 wires, and the key switch, which powers the controller on and off switch, and the throttle. Those were the only things that I used on the very first kart that I built electric, using hoverboard motors. But on this one, I decided to go ahead and just use all these connectors here. So I had to do a diagram to find out what is what here. And what I've done here with this panel is I've transferred pretty much every single connection here to be connected to their individual switches here, because all these things are switched on or off. Some of these connectors, some of these connections, I should say, they use either a high connection, meaning they're to transfer power, high voltage to back into the controller, or they ground the signal. And so some of these switches I'm going to have to modify. I haven't modified them yet, but some of these, when they turn on, these are 3-prong or 3-terminal switches. 2 of them are for the LED, which and the other 2 are either they pass high, or they pass a low signal back onto the third one. And so most of these, they come set up so that it passes the high voltage, whatever you're connected here, and it passes also to the third lead here. So in order to get a switching on the ground level signal, I have to reverse the internal components on these switches, which is basically just an LED and a resistor that is either connected as a voltage resistor in the LED. So then when it switches on the high side. So on some of these, I'm going to have to reverse it so that it switches on the low side, so that I can ground some of these signals back into the source switches, these controllers here. So what we have here is, of course, I mentioned this is the on-off switch. This is the horn. This is a USB outlet here in case I need to connect my phone or charge my phone or use some other USB devices here along with the car. 3-position switch. This is my 3-speed, low speed, medium speed at the center, which is normal, and high speed. And these also will have 3 LEDs here to indicate low, medium, and high speed selection. We have on this side flashers. We have the main lights, and we have a high brake here. The high brake is also going to be tied to the brake, either a foot pedal brake or a handle brake, that connects the 36 to, well, this is when it's fully charged, it's 42 volts, but it's 36, 18, and 18 volts nominal voltage. But when these are fully charged, it's 42. So this connects the high voltage, 42 volts, back into the speed controller via a return line. Actually, this only has one line here, which is it's a yellow. It's a single yellow cable that they designate as a high brake. Where is that? Here it is. So this one right here is the designation for a high brake. The single yellow one that needs to be connected to high voltage, 42 volts in this case here. So this one will be connected to that, and that will be switched to the high 42 volts. So that's a particular connection there that I have to make it so this operates a high brake. I also have low brakes on this side here, which is just a signal to ground. You know, the low brakes has 2 low brakes is this is my brakes here. So this is the low brake, the black and white. And so this one will connect to that switch here, which the only thing it does is it jumpers the white signal to ground. So it's just a grounding switch setup, and that'll be grounded. So this one will have to be modified so that when it switches to the ground and not the high side. This one right here is the cruise control. Cruise control is this cable right here, this black and orange. If you connect these two right here, you'll turn on cruise control. So when this is you're riding this and you want to keep it at the same speed, you can just jumper these two wires, and you'll have cruise control at whatever speed you have set your throttle to. So that's my cruise control that'll be connected to that. It's just a just a jumper switch. So that'll be connected also on the low side, because the cruise speed control is grounding this orange wire to the ground, which is this black wire right here. We also have a reverse switch here, which establishes reverse, low power reverse. So when you switch the controller on reverse, what it does is it reverses the rotation of the motors, but it's in a low power reverse, so it's not too fast. So you can go slowly back up if you need to, or when you engage the reverse. So the reverse switch for that is this these set of wires here. No, that's the brake. The reverse switch is these two wires right here. There's a couple of whites here. These two whites with the black connectors are for reverse. This is also what they call the programming or learn set of wires. This also learns the orientation or rotation of the motor when you first start up the unit. So when you first start up, if the motor's not running in the right direction, you switch this momentarily and you disconnect, and it'll reverse it, and then it'll be reversed, from that point on, until you do this again, with the switch, so this will be connected to that for reverse operation. I have a voltmeter, which also is an amp meter, and this will be connected also to the system power to measure the voltage and also the amperage that I'm using. The horn is just a horn that will be connected, to the either to 12 volts or the full 42 volts via some kind of a DC to DC converter. So I do need a DC to DC converter here to convert the 42 volts into 12 volts, which is required by all these switches. These run on 12 volts DC. I don't know if these can run at a higher voltage, but just to be safe, I tested all these at 12 volts, and it lights up really well. And so I need a DC to DC converter here that I will install either at the back of this unit, or maybe as part of this unit here that sits, assembly that sits at the back of the Go-Kart near the motors. It's in between the motors. So all these connections, I have to make a harness that's going to match these connectors. I already bought all these connectors here, so I have every single one of these types of connectors so that I can just plug in here directly, and then the other end will plug into this board here. But I also need to make connectors here because I want everything to be via connector, so I can disconnect it. I don't want to solder anything except for the LEDs. Of course, they have to be soldered to some kind of a bus that is going to have all the grounds and all the signals, all the 12 volts, all the 42 volts, and all of that. So it's a lot easier to make all these connections to buses, independent buses, with their respective voltages. And so that'll be there, and that'll clean that up. Sometimes when I'm having breakfast in the morning, I tend to sketch things on paper, napkins, whatever it's at hand. And so this is another diagram that I did of the all these connections here. Now there's a gentleman. In fact, this layout here is based on a video that I saw on YouTube of this gentleman that has a table set up with all these switches on his table. And basically he's got all these switches. What I have here, he's got them lined up on a table for test purposes. I've actually done this for operational purposes. So this will go on the car, and then it'll have all the features that you need to um, to work all these connections here, which can also be a test jig. You can use this as your test jig to test all these connections once everything is connected and wired up. So so that's that's the purpose of this guy here. But that other gentleman that from that video, he had pretty much. I was trying to figure out how he had it set up on the table, because he has his own LEDs. He says they're not switches like these. These are lit up switches, but he's got regular switches, just toggle switches on off, or 3-position switches that he's connected to have all these terminals where he can clip with the alligator clips into these posts that are on the table, and he can run signals, to whichever switch that he wants to, and that's how he's testing these controllers. So it's a very nice setup. If you're interested in doing something like that, I would urge you to go watch his video. Maybe I'll put the link in the description below. But you can also do what I did here. Just follow this this setup here, and just have all these switches in the way that I'm going to discuss in either a later part of this video or in another segment of this video, where I show all the connections once I'm done making all these wire harnesses that are going to go into the go-kart. The power system, as I was saying, this is 18 volts, and they're arranged in series to give me the 42 volts that, or 36 to 48 volts that these controllers require. This is a 36 to 48 volt, 350 watt. They're great, inexpensive brushless motor controllers. I've spent much more money for these little controllers for radio control applications of driving brushless motors. I mean, I spent almost two or three times as much as I paid for these guys here, for those radio control brushless motor controllers. But these are great. I mean, they manufacture these things in the thousands, and many companies do these things. So that's the reason why they keep these things fairly inexpensive. These green receptacles here for these batteries are power wheel adapters specifically made for the Ryobi 18 volt batteries. I found these through Amazon. I had stumbled on some really cheapy ones, but these are the ones with the switches, and they come with fuses, independent fuses, and they give you these nice connectors here, which I really like. I actually ended up buying a couple boxes of different sizes, different configurations, so that I can do all my connections using these connectors, because they make life a lot easier. Just you don't have to solder things, you don't have to twist and use the twist connectors. This just plugs it right in, and you clamp it with these little clamps, these orange levers here. So it makes life a lot easier. And so these came with these power wheel adapters. Like I said, these are individually switched. So it's for extra safety. You can switch that on. You can switch once the car is connected. You can switch this on. But if these are not on, both of them on, it's not going to work. So and they have individual fuses. So this is connected in series, and that makes up 36 to 48 volt, and that's what's coming out of here, out of this this connector here. So I have to make from this point here, from my 42 volt, it's going to be my distribution to the rest of the the system here. Obviously this takes 5 volts, so I need a 5 volt regulator. That's where my DC to DC converter is going to come into play, as well as the 12 volt. So I need a 12 volt and 5 volt DC to DC conversion, so that I can go from my fully charged battery 42 down to 12 volts, and also to 5 volts that are required by the USB socket here. This also this doesn't matter, because this connects directly to the battery, and this will be reading 42 volts because that's what you want. You want to read the full voltage of the battery, and this will probably have an alarm here. It's something that I don't show here, but this will have an alarm. So when I drop the voltage below a certain voltage, it'll either shut off or it'll give me a warning. So I can always put a little warning light here, low battery flash alarm here, or I can use one of these LEDs to as double purpose, to make it flash with additional electronic circuitry. So when the voltage reaches a certain point, it'll flash to let you know that it's hey, it's time to shut it off and recharge. The way these lights are going to operate, the left center is for brake, and this one is for right signaling. So when I turn the wheel to the left, that'll probably have a little switch, just a toggle switch, momentary on-off switch it'll trigger this LED here. It'll just engage the LED, with the voltage, 12 volts LED. So we'll have a resistor here, a voltage dropping resistor, because all these LEDs operate at 3 volts DC. Except for these, because they have an internal resistor already embedded in them. So this one will have a voltage dropping resistor, as well as these other ones, as well as these other 3 right here, as well as that one as well. But this one will be triggered by just a switch from the steering column that will turn on left and right, will flicker the respective LED. This one will be tied to the brake. So anytime I engage the brake, either through here manually or through the foot pedal, it'll turn this LED on to indicate that it's stopping. I mean, you don't need these LEDs to tell you whether you're turning left and right on a go-kart, but I thought it would be kind of neat to have those things there, because my kids will be not my kids, but my kids my grandkids will probably be riding this with their dads at some point, and that's the reason why I decided to do this in a colorful way, so that it's so that it's eye-catchy, and the kids love to play with the buttons. My granddaughter came the other day, and we were I pulled this out, and she was having a little bit of a fun, just trying to switch these on and off, and as we're teaching her what's up, what's down, what's push on, what's push off. So anyway, this is where I'm at with this, and I thought I'd just capture a little more video on this particular project. This is Mario once again with MIA Microflight. Stay tuned for more. Thanks for watching.